Given that a wheel with a radius of 15 centimeters rolls a distance of 40 centimeters, what is the angular displacement of the wheel? Well, thinking about the formulas that we started with on the key concepts slide, how do we approach this? And I think maybe a starting point that I'm going to look at is to say, when I say angular displacement, like what does that even mean? My answer is like I think that that's what a delta theta is. In other words, we're being asked for a delta theta value. But there was only one formula on the key concepts page, right, that had delta theta. That was omega is equal to delta theta over delta t. If I'm thinking that way, I might be thinking a little bit too literally because I also had this formula S is equal to R theta. One of the things that I didn't say on the key concepts video is that alternately, if you wanted to, in terms of notation, you could describe this as a delta theta. And I think, and in that sense, maybe you could say this is a delta S. I don't know. But I think the argument that I'm making here is that this arc length could be represented by some change in angle. I mean, the way we interpreted that formula geometrically earlier wasn't really a change in angle. But if I kind of say, hey, we're talking about a wheel rolling here, I think the distance it rolls corresponds to the amount of arc length that it kind of like rolls through, or I don't know how to put that into words, but like makes, like if you look at the distance on the wheel itself that makes contact with the ground at some point, that really is an arc length. And that's why I'm thinking this formula is it. And in that sense, delta theta represents the angular amount by which the wheel has rotated. And that makes this problem relatively simple once we recognize that, because then we can say delta theta is equal to the ratio of S over R. And if I represent S as being that 40 centimeter distance the wheel rolled, and if I represent R to be the 15 centimeter radius that we are given, and then I go to my calculator and do 40 divided by 15, and I think that winds up as a mixed number fraction type thing. It would be a 2 2/3, but like a 2.666 repeating, but maybe in this case I'll just round that off to 2.67. What unit do I put here? The thing to notice, of course, is the centimeters cancel out. And this is why in the last example we had a little bit of a discussion about the nature of angular units. The way the radian is defined, this is a measure of an angle, and I can optionally throw it in. It's dimensionless, so the fact that all the dimensions have canceled out doesn't prevent me from using it. But it's also perfectly okay to just not even write a unit. That is actually kind of my preferred habit to do. Let's check this in the answer. So it says here, it looks like I took my choice is kind of aligned with this second one here, but it did also, if somebody else said, hey, it's 2.67, either wrote in word radians. I've seen some people use like a capital R abbreviation. I think that comes from some trigonometry books. That's okay, I suppose. It could be confusing, I guess. Again, I kind of prefer not to use the unit at all.